Okay, in tonight's video I'm going to tackle a Toshiba, it's a CRT set. We have a color problem on this set. I'll turn it on and I'll show you what the problem is. Well, we got a couple problems with this TV. First of all, this TV's got some nasty burn-in. This is what happens if you leave the same image on your TV too long, okay? It's got, you can see it here, the actual phosphorus has been burned. That's because this set for many years was used as a security monitor. This goes back to July 1989 was the date of manufacture for this set. And this one again has developed a color problem. So we'll turn it on here. I'm just injecting a color bar signal. And as you can see, I've got it going into my channel 13 modulator. But as you can see, we have a black and white picture. Now you can actually see, you can see the grid here. The crosshatch, there was a black line, I guess there, or white, yeah, black line, because it's not burned. It was a 4-camera display, and you can actually see a shadow what was on the image here. Again, this set was, this TV was running 24/7 for many years as a security monitor. You can actually see where the time information was burned in at the top here. Anyway, there's no color on this. And I think if I go in, I'm just looking for the, I've got the back off this set here, so I'm just looking for the color control and stuff just to verify that it is not turned down. The color, as you can see, is cranked all the way up, but there is no color. So what we need to do is we need to actually scope the chip on this thing and see where we're losing it. Now, I've hunted for a schematic for this TV, and unfortunately the way the internet has gone these days is it's getting harder and harder to find schematics that people don't want money for. And I'm sorry, but I'm not paying $25 for a print for this TV. So I had to settle for a pinout of the actual IC. This one uses a TA8680. TA8680N is the IC on this one. So I was able to look up the IC number and get a pinout for the IC, which will be fine. We can now scope this. When you work on a television such as this, it is imperative. This is a hot chassis. So in other words, there is no transformer. The only transformer in this set is the flyback transformer. What that means is that the AC power is connected, one side of the AC line is connected to the chassis itself, and they usually have one prong is wider than the other so that the neutral is always on the ground, but that only works if your AC power is properly polarized. I do have an isolation transformer on here. You don't see it. You'll see my variac, and incidentally, variacs are not isolation transformers. They are a variable voltage transformer, but they are not, I repeat, not isolated. I actually have a separate isolation transformer. You guys don't see it. I've shown it before. It's under the bench. I'll show you where it is. So there's my isolation transformer. Everything on my bench is protected. So basically what I do is this variac here that my TV is plugged into, it is plugged into the isolation transformer. So this is isolated. This little power bar here is plugged into this. It's also isolated. I don't isolate my scope. I have no need to isolate my scope because the equipment that I'm working on is isolated. But if you're going to work on this type of equipment, you need to isolate your equipment or your scope. Preferably isolate the equipment that you're working on. Isolating your scope might protect your scope from damage if you hit a power rail, but it won't protect you from damage if you're touching something that's grounded and you make contact with something that's got energy on it. So the isolation transformer not only protects your equipment, it protects the servicer. So now that safety's out of the way, I'm going to turn on my scope here, and we're going to start looking for signals on this IC and find out where we're losing our color and why we're losing our color. Now the first thing we have to look at when we've got a color problem, which we definitely do on this one, as you can see there's no color on the screen. In order for color to be demodulated, we need to make sure that our crystal is actually working, or our subcarrier regeneration, which is off of pin number 13. So I'm just going to scope pin number 13 and verify that the crystal is actually working. There's typically a little capacitor that's in series with that crystal, and if that little capacitor were to break down, short or go open or something, and cause the crystal not to work, or if the crystal were to become defective, we would have a picture with no color. So what I'm going to do is I'm just going to scope pin number 13, and we're going to look to see that we have our 3.579545 carrier, because that's the first place we have to look. If that's not working, we're not going to have color. Now this is valid for NTSC. If you're dealing with a PAL set, it would be 4.43. But let's find pin number, what did I say? It was pin number 13. Let's find pin number 13 here, and I'm going to scope it and see what happens, and see whether we have anything. Try not to electrocute myself at the same time. So 1, 2, 3, 4. I hate these things. There's so many pins. Let's say 13. Yeah, pin 13. That's pin number 13 right there. Okay, it looks like we actually have an oscillator running, doesn't it? Let's see if I can make sure that that's actually pin number 13 that I'm on. I'm going to double count here, make sure. I'm on the right pin. Pin 13. Okay, that's pin 13 that I'm on, and it does look like I have an oscillator running, but it certainly doesn't. Okay, so I do have an oscillator, so that means that my crystal is working. So I have to look elsewhere because it appears that I've got my signal. You can see it here. This is my color. My color generation is there, or my color burst, or I should say my subcarrier regeneration is there. So if it's not running the right frequency though, I don't have a frequency counter here. If we're a little bit off frequency, it could cause it to, it could be muted in the color killer circuit, because if you look on here, there is a color killer. So just got to check my levels here. I have a feeling. I've got the set running here right now, and I'm going to just stick my fingers in here where I probably shouldn't. I just want to see whether I'm just going to touch the crystal here and see whether we might be just a little bit off frequency, right? And oh, look at that. So what I'm doing is I'm touching a capacitor. On this one, it's C504. And I'm just putting my finger on this capacitor ever so slightly. There we go. See that? So what I'm doing is I can do this because the TV is isolated, so I'm not going to get a shock, and also this is not high voltage in here. But what I'm doing is on C504, I'm just providing enough extra capacitance through my hand that I'm changing the frequency just enough that now the set is locking in and we're pulling color. Interesting. Sometimes you know, you do what they call the wet finger trick, where you lick your finger and stick it on. I mean, I would never advise that for someone. That's what old techs would do, is they do the wet finger trick. They lick their finger and they just start probing around in some of the low voltage circuits. You certainly would not want to do that on a television. I would never advise someone to do that because there are hazardous voltages, like down here in the flyback transformer. There's some very high voltages down here, but over 1,000 volts peak to peak. Now, what I mean, I'll show you here on the scope. We'll just turn the scope down. I'm going to crank the gain way up. I'm in a ×10 reference on it here, and I'll give you an idea of what kind of voltages we're seeing on this thing, because it's so you got to really be careful if you're working on anything on a CRT television, because there's 30,000 volts on the picture tube for one, but even without being on the picture tube, we have some very high voltages. Like down here, I'm on the horizontal output. Okay, look at the voltage that we've got on this. Now, I want a ×10 probe. This is 10 volts times 10. So each division on this is 100 volts. Here's our baseline: 100, 200, 300, 400, 500, 600, 700, 800. We're off the end of the scale. 900 volts, peak to peak. There's our peak right there. Right? And we're about 1,000 volts here. Because here's the baseline at the bottom of the screen. 1, 2, 3, 4, 5, 6, 7, 8. That's 800 volts top to bottom. And our peak is even beyond that. So we're talking some serious power here. 1,000 volts peak to peak. You don't want to stick fingers in there, folks. Very dangerous. In this circuit here, we're talking, it's on a 12 volt rail, if that. So we're not talking much power, but in this area here, we're talking some very dangerous voltages. So you got to really be careful if you're working on any type of CRT set. I'm going to change that capacitor C5, what was it I say it was? Unplug the TV here. I'm going to change that little capacitor here, C504, and see whether I get back the color. I'm just going to see what size it is here. So that's the little one there. It's a small little ceramic. Gotta see what value this thing is and see if I can find one that's close to this. It's like an 11 that's printed on that. Gonna get my big magnifier out here. So that's a little 11 picofarad. Let me see if I can find something, maybe a 10 or something in there. We're gonna replace that little ceramic and see whether that will fix the problem on this. This is the one I was just touching my fingers across the pins, and every time I would press on it, the color would come back. So I've got a little 10 here. I'm going to tack it on the bottom of the board here for starters, and we'll see whether this one's actually, we'll see if this 10 is going to be good enough to give us our color back, because I don't have an 11, at least I couldn't find one. I'm just looking through some old scrap boards, right, for little ceramics. I do have this 10 picofarad. We'll put that in there and see. Now this set here, we're going to see this set a bit, because I'm going to probably create some faults on this set at some point. I just hauled this one out. This is actually one that I've had for well, since probably about 1990 or 91 when it was given to me. And I was using it as a camera monitor here. Actually, it was probably, I'm going to say it was probably 93, because it was 93 when I moved in here. So I've had this thing for many years anyway, over 20 years. And it was a TV that somebody tossed, and I picked it up, and someone brought it into the shop to be repaired and didn't want to spend any money on it, so I fixed it and brought it home, and I used it as a monitor. But up until a couple of years ago, it was fine. Then when it lost color, I just put it away. So this was a breakdown that happened on this set, and I just never bothered to get around to fixing it. But I am going to be using this set. We'll create some faults. I'll do a couple common things on this, and we'll find a few more things to do on this set. But this actual breakdown, this was the way the set has been sitting for the last couple of years. So I'm going to mount this 10 picofarad cap in here. I'm just going to tack it down to the bottom of the board for now. And we'll see whether we get our color back. If I don't, I'm going to have to find another one that's the right size. But let me get set up here. I'm just going to flip the board up on this side here. And I'm just going to tack this down to the bottom and see whether it works. If it it works, I'll put it on the top side. But for now, I'm just going to tack it in down here and see what happens. It's always faster just to tack things on the bottom, right? Especially if you don't know. It's not quite the right value, but I'm thinking it's probably for what this is, for what it's doing. Whoops. It should be good enough, I would think. Okay, we'll try that. See if we get any color. I would say that that's affirmative. We have color. There you go. That's what happened on this. So that capacitor, I'll show you on the schematic here. It's right here. Zoom out. So that capacitor was a series capacitor for the crystal, and it either went up in value or it went down. It probably went down in value, I'm thinking. Maybe it even went open. And basically what I did was I just put my finger across here, and the resistance from my skin was enough to get that crystal oscillating. And as you can see, now we have color on this set. So, problem is solved. I'm going to mount that part through the holes on the top, and we'll call this one a day for this TV. But before this one goes back together, again, I'm going to do a bunch of videos on this set. I'll simulate some other problems with it. Maybe we'll do some problems with the vertical. I'll put some old bad capacitors in the vertical, some of the common ones on these sets, to create some of the classic vertical problems, and then we can look at it with the scope. So say when I put this one on here, this is I'll put the meter, I'll put the scope back on here. Now we can take a look at the crystal now that it's working properly. So that should be the one there. I think that's the one. Yeah, there it is there. And that's actually stronger too. That's actually, I got more. Yeah, you see, if we looked at what I had before, the levels weren't right. It was much lower. So that's the crystal working. So that's what the problem with this one was. So hope you enjoyed this video. Hopefully it wasn't too boring. Hopefully you figured things out. Again, if you guys are going to work on electronics like this, CRT sets, do be careful. As I showed you, there's high voltages on here, and you can get hurt. Always use an isolation transformer. I can't stress that enough. Don't even attempt to work on one of these things unless you've got an isolation transformer. Or if you don't have an isolation transformer, keep your fingers out of it when it's plugged in. Right? If you're going to try changing parts, make sure it's unplugged before you get your fingers in. I can't stress that enough, because as you can see here, if you read what it says right here, caution, big red sticker, and you guys can't read it, but you probably can now. Caution, this heatsink is connected to the power line. This is directly connected to the AC line, and all it takes is if you're not isolated, you touch this and you touch ground at the same time, and you complete the circuit. Be careful. Now, of course, people wonder, what the hell would you want a CRT set for, right? Hey, they're the ultimate things for playing retro video games on. Can't beat them.